thank you. Welcome back to PendulumLost. Again, it was hard getting you here for a second time, but we're going to keep going. So if you want to introduce yourself again, and then obviously what you do. Obviously, we discussed you kind of your background briefly in the previous podcast was mechanical engineering. But let's dive deeper into that and let's have this discussion about what you exactly do and obviously renewable energies. So if you take it away, Gurpal.
Yeah, sure thing. So hi everyone, my name is Gurpal. So I'm a mechanical engineer working in first energy efficiency and now more so in renewables and going carbon neutral. Carbon reduction, and is that like a big trend, let's say, at the moment with government funding and grants, etc. But yeah, so that's what I do as my day job. I never planned to be an engineer when I was growing up. I actually wanted to be an architect when I was much younger. Loved doing fine art.
That's something we've got in common, actually. I really wanted to get into architecture.
Yeah.
So to take the spotlight off yourself there.
No, I love drawing and stuff
that.
like that. But then when I got a bit older, basically my brother is a doctor now, but I was like, I'm never going in the medical field. I was like, no, thank you, not for me. But I was better with numbers. So I thought, okay, engineering sounds good. And then got picking our A-levels and stuff like that. So I thought, again, I'll pick towards more maths and physics. I took English and law, which was never going to happen. and dropped law.
I think that's with every Indian parent. Law, medicine.
Exactly, yeah. My dad literally was like, yeah, you'll be good. He's now going to do this. Do you want to become a lawyer? No. No, thank you, mate. But yeah, I dropped law after first year, changed English to psychology. So it's very much geared towards maths and physics.
Yeah.
And then when I was then looking at unis afterwards, implying I realised architecture is a 7-year course, so I was like, no, that's not going to get through that. It's very long.
I never understood why architecture course was so long. Like it's on par with like
you
doctors.
go into industry, so you do years in industry. So it's like I think you do 3 years, then you actually work, and then you come back and you complete your There's like a legal part to it. There's you can go into like BIM modeling, which is like more so with computer science, everything like that involved. And then you become like a qualified, even like building regs and all that kind of stuff. I think that's why it's
you
much
can't just
longer.
draw a building and be like, there you
no,
go.
yeah, exactly. Yeah, that's how stuff.
I think that's what our dream probably started. Let's just sketch a building and
it's
send
not
it
like
off.
up and making an outhouse.
They don't even use drawings. There's no drawings. It's just an idea.
It'll be okay. It'll be okay.
I see a plot of land and I see I have a vision to build something.
That's all it was, isn't it? But yeah, so with mechanical engineering, sometimes people get it confused with automotive engineering. You think mechanical, people think mechanic cars, right? But it's not actually that. That's automotive engineering and automobile engineering. You get aeronautical engineering, which is airplanes. Mechanical engineering refers to mechanics and maths.
Yeah.
If we ever did those modules.
So it's almost like a base foundation before you branch off into specialities, right?
Yes, precisely. So mechanics and maths, in very simple terms, is you have a particle and you do the assessment of forces on that particle. So that particle could be a building, it could be something as small as, let's say, a grain of rice. It can be something huge, it can be a massive building. And then you go into the stress analysis of it and flow rates and all this jazz. And then mechanical engineering in, let's say, when you become into professional terms, becomes on mechanical systems such as water pipe work, gas pipe work. And you're designing then from small 1 inch to 1¼ inch pipe to then 300 mil pipe and stuff like that. So it's a very, very broad, let's say, engineering subject, but it's a lot of fun if that's your thing. Yeah, and then my role went more so from learning about design and being able to do high-level assessments and surveys into then implementation of those solutions. And that's basically what I specialize in as a project manager. Is basically you have the idea, but it's how do you actually go and install it, and how then we can dive into is how is it funded and where does the money come from? Is it private sector? Or is it public sector? And then following implementation, we then have to verify, did we actually achieve what we said we would? So if you're, as an energy efficiency, the name of the game is bring the bill down. Have we actually brought the bill down? And how do we assess that? So there's a whole measurement and verification process that we have to as part of our contracts, which means it's so great for clients, basically, because they don't actually have to pay us unless we prove that we say what we did.
Yeah.
So that's basically what I've been doing for the last 13 odd years now as well. And it's good, it's
cool. So one thing before we kind of move on to some of the teams, because you got to work part of a big team, right? It's not just you doing mechanical engineering and you just kind of...
No, it's not a one-man band by
there's like a horizontal team, right? Not like a vertical in terms of like management and stuff like that. It's a team around you, right?
Correct.
So we'll get onto that in a minute. But before we move on to that, which will lead up to that question, right? So this is more for like it's a twofold question. One is like getting people more involved in mechanical engineering, because I think that is the way forward. I think the vast array of things you can do off the back of mechanical engineering is amazing.
Yes.
Because I mean, I'll let you highlight some of the subjects, because it's not mechanical. You've got structural engineering, and you've got other elements of, like you said, aeronautics engineering. You can go into so many. But even for yourself as an individual, you become so proficient at just doing things, right? You can actually go off and build stuff. You don't need to go just look for, I mean, you obviously look for a job and work for someone credible, right? But I've seen so many people just take on home projects with that understanding of like mathematics, physics, well, chemistry, if that's involved as well. You can do so much just at your home, you know, and build stuff and build yourself a reference CV. I've seen people like try and like make their own, what's the topic we're going to talk about, making their own homes energy efficient, right? These are projects you can do when you have the foundation understanding. So I just want you to iterate like how important it is, like mechanical engineering, and obviously what it can lead to, but also for kids, like, you know, I think everyone's doing how fun it can become, you know.
Definitely.
Because a lot of people, like, a lot of the jobs they do these uni degrees to look for a job, right? And then they have to do that job. It's not something like, for example, you can't be a doctor at home and treat yourself, right? I mean, some people will, don't get me wrong, but you can't bring people out. But when you're an engineer, you can do whatever you want to your house, you can tinker, you can just go nuts. Like,
no, it's a really, really valid point. So this is one of the reasons why I picked mechanical engineering as well, just when I was picking a degree. So at that time when I was at university, grad schemes was like the big thing, right? So you get your degree and you go into a grad scheme. I was like, what would make me eligible to apply to these different places? So, and that's when I realized I could apply to IBM. I could go into computer science and that kind of what. I could apply to Deloitte and go in toward banking, or I could apply into any engineering kind of field, because mechanical was a very diverse, even at the modules for it. It's not just you're learning that. We're doing bits of computer science, we're doing a bit of project management, we're doing bits on materials, we're doing bits on ethics even as well, because again, within engineering, ethics is a big thing. And you'll be surprised, in this country there actually are a lot of rules and regulations, whereas in other European countries there's not many. You'll be surprised. Health and safety is a complete DOS in some places.
But they do progress a lot quicker because of those lack of restrictions. I mean, you get a bit more freedom. I don't know whether that's a good thing or a bad thing.
Getting the job done is one thing, but it's not worth the risk as well, especially if you're, as a project manager, for example, I am accountable. If something happens on one of my sites, one of my projects, fundamentally it will come down to me. And this is the one thing we're taught, it's not worth it. If something's wrong and you know it's wrong, don't cover it up. Because if it failed in the future, like you look at Grenfell, and this is like the ultimate example that's given now, an absolute horrible disaster happened, but they kind of knew that was the risk of what could happen as well. And it was just, no, just let the building see itself out, tenants will leave, and then we'll redo it. They should never have waited. Never, ever. But back to the original question. And so with engineering, in very, very general terms, engineering is problem solving. That's all it is. And if you have that thing, like if something breaks in the house, I'm not going to call someone to come and fix it. I want to take it. If it's actually broken, I just want to take it apart and see how it's put together. And I remember when people used to build their computers and stuff like this, and that was like a big thing. People loved that IT boom back then, like building your own supercomputer. And it was like, I didn't really get it, but now I kind of get it. Because if something else breaks or something has happened, I'm more intrigued about how does it actually work. And it's such a good skill to develop, like you said, for kids and everything like that if there's a problem, don't give up on it. Try and figure it out.
I think that that failing and troubleshooting, it needs to be made more fun. Because I've seen a lot of kids now, especially around maths, if they don't get it, they get so upset. And they feel like they're dumb and they don't understand it. And then they just don't want to touch it again. And they fall further and further behind. And I see that a lot in university. Not university, in school, sorry. I see that a lot where they just keep falling behind just because of maybe one experience, or like maybe for a duration of period, they just didn't get the subject they were getting on. And rather than approaching it as, look, be a detective, this is a maths, it's a problem that can be solved, have fun with it. Even if you get it wrong the second time, look, you're making progress.
It's actually having that pragmatic approach to it. And the weird thing is, Taj, I think it's weird, it's happening more in industry as well. Like AI is great, right? But now if someone's got any problem, they're just going ChatGPT, and you're like, but we are qualified engineers. This is what makes us engineers. Like we are. How else are you going to learn?
It's human nature to kind of like it's in us to inherently to do things, fix things, and move forward. If that's taken away from us, like AI, don't get me wrong, I'm not going to talk about AI too much on this podcast because that's a whole issue in itself. And people like Elon Musk and Mark Zuckerberg are not helping the situation because they're tiptoeing around the fact that so many people are going to lose their jobs, what the consequences of. You can hear it in other podcasts.
Yeah, it makes their businesses more efficient.
Yeah, exactly. They're making money. They need to be on top of it first, and there's no kind of care or anything to what's going to happen around them. They just want to be first. So that's a whole different conversation. I don't want to get into that too much. But you can physically see the achievements of like people doing engineering. You can see the successes. You can see the excitement when they want to try and build stuff. You see it in kids. When they do like simple as building Lego. Like that's such a simple form.
That was my favorite thing to do. Yeah.
Yeah, I'll get my kids. Like, TV will go off. We've got a whole bag of Lego. I'll be like, look, if you're bored, go make something. I don't care what it is.
Even just for imagination, like you said, just make something, and then they'll make it, and then you look at it, some people are like, what is that? And they'll tell you what it is, and we're like, wow.
Yeah, I don't care like what it is, but the fact that you sat there for an hour and that's what you come up in your brain, it makes absolute sense.
The other one for us is like we've got our little one tools. It's like little tool sets at home, like learning how to use a screwdriver and just doing hammers and stuff like that. Some people don't know how to do anything. Yeah. And like fair enough, they're each to their own kind of thing. But we want our children to be like hands-on. Like our folks, for example, if something was broke, they did not call anyone. Exactly. They could break it even more.
One of two things happening. Either got fixed, or we keep using it,
or there was like a very like weird way of how it worked, kind of thing. Like you've got to move the tap like this much first, and then do that, and then
that didn't actually fix the problem. It works like this now.
There was a lot of pride. Like my father, even my mum. It was like, they would try and fix something first, and that's how we've been raised as well. So rather than, and that's why I love engineering. Even what we say to like new juniors who come into the business and stuff like that is like, whenever they have a problem, we always say ask questions. And that's the thing. Sometimes people are too scared to ask questions.
Yeah, because it's asking questions is a very good thing. But sometimes I think people are failed to make like they're feeling stupid.
They think stupid, and we always say to them, no, there's no
don't get me wrong.
thing,
there are some people that make you look stupid. There are some people like that, and that's very unfortunate because they want to keep their position protected or whatever it is, or they'll look down on you because of power, whatever it is. It's almost like they don't want to share the knowledge. And unfortunately, there are people like that. But if you do get into the right role, or you can teach yourself, where you can make mistakes and learn, it's absolutely amazing.
It's everything. It's like we were saying, just in general, in a good business anyway, the whole thing of having a team as well is that you can rely on each other. Otherwise, how is anyone else going to learn? And
exactly.
It's either that, and it works as let's say someone who's more senior. It works to your benefit because then you don't have to be everywhere all at once. You physically can't do it. Like we have works happening at night, and then we have another team coming in at 6 o'clock in the morning to take over to carry on the next bit of work. If you're not delegating and you're not passing on knowledge to the teams who are doing, let's say, the night work, all of the team is doing the day work straight after you finished, you're screwed. And you're never going to be able to switch off. So delegation is massive, but passing on knowledge. And what we say in our business, I have to rate the company. I work for a company called Amoresco.
I was going to say, you didn't actually mention them in our last podcast, because they did actually help with the whole charity. I did want to obviously mention them.
I'll quickly divert back to it. But one of the things we always say, there's no such thing as a stupid question. It's better to ask and clarify than do something and be like, mate,
if that stupid question is unanswered, that could actually lead to a mistake.
A huge mistake.
Exactly.
And mistakes in our business will lead to someone potentially getting badly hurt or more, even more serious, fatal injuries. Because it's big engineering. Like I said, it's a big, heavy welded pipework, hot water, hot steam, live gas. Things go wrong, something's going to go pop. And it's not pretty. So we say there's no such thing as a stupid question. It could take 5 seconds to ask it, and you can literally say, no. And they're like, oh shit, I was just about to do that. And you're like, no, don't do that. Explain why you don't do that. I'm like, oh, of course. Everyone knows the fundamentals of it, but just sometimes you might think, oh, close that valve. And you're like, no, if you close that valve, you're going to get massive pressure build up. And when you're going through, and we can dive into this a bit more later, but different stages of the projects, if like part of it's not commissioned, you have to operate it differently to when it is commissioned. And that's with the IT and the brain part of it. You can have the best system in the world. Another part of our engineering project is BMS, Building Management Systems. That's the brain. If that's not programmed correctly and is not telling the enable and disable signals to go out when they should be, it's all pointless doing it that way.
So I mean, let's obviously or highlighting how important obviously a mechanical qualification could be, or degree, or even a study, and obviously how I think everyone should be doing it, to be fair. Let's talk about your teams and obviously
Yes.
the kind of the teams that you work around. So it's not just you doing your thing.
No,
How do
it's not
other
a one-man
teams?
band for
Yeah,
sure.
so let's talk about how your teams also integrate the input in. So let's pick an idea. So I'll let you pick an idea, and then if you describe the input and the team and the development of
Yeah,
that
sure.
idea.
So I'll quickly go into the companies and then how the teams have evolved from them. So when I first got my job was with a company called Energy Excel, which was a small boutique company. And our roles more so were in the private sector then. So I worked, my main client was Dixon's, who own Curry's PC World.
Yeah.
And we were doing projects then about like major lighting upgrades. So this is where the whole transition about 15 years ago was between fluorescent tubes into LEDs. And that was the biggest thing that was going around, and massive energy saver, because you got, for example, on average 58-watt tubes, and you're going down to 17-watt LED array.
Yeah.
And you do that across your whole estate. It was just a fantastic win. And in general, better lighting, more uniform, better levels. You see with tube lights back in the day, they'll go more yellow as their life cycle comes to an end, whereas LEDs last longer, technology is better. So with a project like that, which was like, we did a whole bunch of Sainsbury's as well. So all your Sainsbury's supermarkets, we were part of the framework there that did all the cross-floor fridge and freezer cabinet lighting, all the back of house warehouse lighting as well. So within just that one project, you would have the lighting designers who would be doing their work. You'd have the survey team that would go in and literally look at everything. We've got the HVAC system, which is heat, ventilation, air conditioning systems. So within your fridges and freezers, different temperatures, different lighting systems. And then you've got implementation, which is obviously you've got your project manager, then you've got your site auditor, you've got QS teams, you've got commissioning teams. So every step of the way, you've got someone who's, for example, gone in and done the original survey, passed that forward. Then you've got the design team who create the design. Then you've got the implementation, say how feasible is it to install that design. And then once it's installed, you've got the QS who will come and say, have you installed it correctly? And audit it correctly. And then as part of our job, which is in the energy efficiency, it's, are we making the savings that we calculated that we would do? So we have models.
So how just quickly, how are those kind of calculations made before the implementation? Because I'm assuming obviously you do testing like beforehand, but then testing in the real environment could produce completely different results. So how do you kind of bridge that gap to try and match that as closely as possible to the actual real environment?
For sure. So as part of the survey, we have very detailed modeling, basically where all the information is fed into. So you'd have a database essentially that will show as a very simple line item that if we've got this type of light, there's this many of them, these are the running hours from them, and we say, okay, this is the kilowatt hour that those consume. Now, straight away, if you know that you're going to replace that 58 watt with a 17 watt, you just do the same calculation, put the 17 watt in, and that will give you your target number, and a bit of safety factor and other bits that you kind of give yourself a bit of a buffer. The way we measure it is that we have sub-metering everywhere. So the distribution boards, where all these lighting circuits are fed off, you put a meter on it. That meter gives you your true reading. Now, I say true reading, as long as it's accurate. There could be bits that are missing. You could have other loads that are added onto it in the future without getting too technical. But you might think something's a lighting board and it's got 20 circuits, they're all lighting. Over the years, somebody's changed something up, circuit may have failed, circuit's been added on. So sometimes you hang on, that doesn't seem right. But sub-metering is a massive thing. And on top of that, as you mentioned, we have to do a sample of actual physical readings as well with the electric meter. So again, we would have, as part, say for example, we've installed 2,000 fittings, we would have to sample at least 15 to 20% of them. You can either do that at circuit level at the board, or you can do it actually at the fitting itself, whereby you physically take the measurement before you change the fitting out, take a picture. We have to log it, take pictures of all of this, and then you put the new fitting in, you take the picture of that, again take the meter reading, and then you say, yep, there was, on the survey, there was 10 fittings, for example, in this room, there's 10 fittings now. Or what we do to make it more efficient, especially with LED lighting, is you don't need as many lights as you used to back in the day. So before, people were like, yeah, you would need to have, for example, 10 fittings in a room. You could achieve the same lux level, which is the lighting level, with 6 fittings now. And again, but that's where we come in. I say as a specialist, it's a very simple example of a let's say a more simple project, but it's not just about changing it for the technology, it's how can you actually rationalize the design and make it more efficient. 1 for 1 is very quick. So if we went to be a cheeky company, we could say, yeah, we'll do 1 for 1 this year, and then we'll come back in a year's time saying, oh, the technology's evolved. We were never about that. It was like, look, what is the best solution that you can actually give to the client now? And that's where we showed the value as a company, and where we show as engineers, it's not just about anyone can go and change the light, for example, but it's like, what is our USP? What are we saying that we can do better as a service, as a company, that we won't subcontract this all out? These are all in-house engineers as well. Like you said, you might sell the project that this company is going to do it, and they've subbed it out to A, B, and C, and you get a terrible delivery on the back end of it. One of them's gone bust, for example, and you're like, the client's like, what the hell happened?
Yeah.
So that, in a nutshell, is like one of the simpler projects that we do, and touches upon the different teams. On the electrical side, in the mechanical side, we do a lot of leisure centres and swimming pools, for example. And you'll see there, just to heat their big pools, it's a lot of energy. You've got pumps going, there's a lot of heat going into the pool as well. You'll have aircon systems to make sure it doesn't get too humid in there. So you've got to have extract fans pulling the humidity out. You'd be surprised, a lot of pools don't even have pool covers and stuff like that.
Yeah.
But on the pumps, you might have very old, inefficient pumps. Technology's changed, you've got much better pumps. They're quieter, they're smaller, but they're more efficient. And you can install what we call a variable speed drive on them, which means, in very simple terms, they don't have to kick at full power. Before, technology used to be on-off.
Yeah.
Now you have modulating and variable speed. So dependent on the demand, they will spin as fast as they need to spin.
Yeah.
And you do the same on your ventilation fans. So the big fans where you extract that's pulling out, if it's nighttime, you got your pool cover on, it's not humid. You don't need your fan kicking out 1,000,000 miles an hour. So you ramp it back. So it's having the team who's skilled enough to go in and identify what is the systems in these areas, how are they currently functioning, how do we optimize that, and furthermore, how can we replace them with something better? So that's in a nutshell in some of the different projects. The different engineers we have in our team.
Cool. So let's move on to the next question. So the next question was discussing the current state of like renewable energy.
Yeah.
Like, where are we from? What the goals, the government goals were set with obviously the CO2 emissions and stuff like that. Some of the goals and the buzzwords.
Yeah.
To where we are now.
Yeah.
What's the general landscape, just with a broad kind of brushstroke? Because obviously we don't want to get into too much, because some things move faster than other things and setbacks. But just where we are right now in 2026, where are we?
It's a good question. Like I said, so like 13 years ago, I was with Energy Excel. Energy Excel got bought out by Ameresco, who I'm with now, and they changed the whole business strategy from private sector into public sector, which was heavily focused on renewables. And it's because of that, because the government is throwing a lot of money into the sector to make it, like I said, carbon reduction programs. There's 2030 targets, there's 2050 targets, and then there's renewable. There's a lot of green grants that are coming in. It is very good. Yeah, in very simple terms, it's a very good place as a sector to work in. It's a great place to be as well, because the projects are getting much, much bigger. So it went from energy efficiency into now carbon reduction, and that is the absolute name of the game. It's not even renewable energy. It's just about reducing use of gas.
I mean, you've got a few buzzwords there, because you've got carbon neutral, right? Which is quite misleading. And you got CO2 kind of, what was the buzzword? CO2 neutral, whatever. Not neutral.
It's just
net zero,
Net zero,
net zero. And they mean completely different things, right?
Yes.
And then you got renewable, environment friendly. Like, obviously they're not buzzwords, but in type of this field, what does that mean? Because obviously one is obviously trying to make the same emissions that you put out, you kind of reduce you level them out, right?
So that's the thing. A lot of people think being carbon neutral means you're not producing carbon anymore, which that's not the case.
Yeah.
It's like you said, you're offsetting what you produce
I mean,
by introducing
a good example,
systems.
just so people understand, would be, so say for example, a new kind of power plant opens somewhere and it's producing an X amount of CO2. They'd go and buy a field somewhere, just plant some more trees and be like, look what we're doing, we're neutral now, because it's offset.
Or they'll change all their vehicles to electric.
Yeah,
for example, they'll be like, all of our FM guys, facility management, maintenance teams, we all use electric now. That's what it'll be, for example. So we're offsetting what we're producing over there by doing this. And like I said, we've planted a whole bunch of trees, or we've got solar going and stuff like that. So that's just a very, like you said, important thing. Being carbon neutral doesn't mean that you're not producing carbon. We're inevitably going to produce carbon. Just going to work, you produce carbon.
Exactly.
But what is getting better is even when batteries came out, for example, like for electric cars and stuff, it's the batteries that go in these cars. The manufacturing for those used to create a lot of carbon. And that's why everyone's saying, okay, it's great that we're using electricity now, but to create those in the first place, you create a lot of carbon. And when they become redundant and you've got to get rid of them, they're going to produce a lot of carbon. That has changed drastically. The technology is so much better now, and people like I said, with Elon Musk and Tesla, they'll validate that, no, we don't produce as much because the actual technology's got better, the batteries are smaller, they're more efficient, and they've got more use for afterwards as well. They're not going to get chucked into landfill or something. So when it started, it was like a very big buzzword. Yeah, we've got to do this, but it was done shit.
Yeah.
Basically, it was done really poorly. And even like solar PV, for example, the panels now are so much more efficient. They're so much smaller. Even the way they're manufactured is better. But back then it was like, no, we've got to get solar, and you just get it from here, there, and everywhere. And that's where, unfortunately, where we touched upon ethics very briefly, where they're sourced from, unfortunately, places like China, there's slave labor there, where the specific materials that go into the panels, it's mined effectively out of slave labor. So again, when I touch upon regulations, in this country, we can't source from those countries or from those specific suppliers.
Yeah. I mean, we're going to talk about this a lot more, but because of that, the cost of things go up.
Yes.
And obviously, we'll talk about cost a lot later on once we get more into the technology that are available, especially in homes and stuff. But if we stop producing any of these, like you said, there's some of the rare materials that go into producing these things. Where, as a UK, we don't produce these.
No.
So then if we can't source it from where obviously they are mass produced and the cost can come down, how are we supposed to move forward? Because the cost of, where is that cost going? Because couldn't we just put the cost of that into producing facilities that can mine the materials, can produce it, so we're not going somewhere else?
Yeah.
Because there's a massive cost that's gone into renewable, like say wind farms and stuff like that. But then they're sourcing it.
As well now,
so they're sourcing it from somewhere else. Once they kind of wear out, they're not kind of reusable, are they? They're not recyclable to an extent. And they're going somewhere else. I mean, we don't have the recycling facilities. We don't have the development facilities. Why not just put that money into developing it right from the get-go and everything that goes around that infrastructure? I mean, just your opinion on something like that.
From what I can tell, obviously, I think the more so what the government's trying to do is inject the money in so they can, it goes into consultancy firms to go and implement. It's not into actually manufacturing. Like you said, the country does not manufacture these huge things. It's just financially not viable. I think overall, I can't really dive too much into it, but I think with UK being quite small as well, I don't think they've got the space to actually just be in a place where they can mass produce these kind of things. And then push them out. It's just, even you look at, in general, from Brexit happening, it was, this will be done in-house, we're going to do this, we're going to do that. Fuck all's happened.
Yeah, exactly.
They physically can't do it because there's just not enough space on land.
Steel factories have closed down.
Mines closed down back in the day. Yeah, exactly.
So we're after Brexit, we've actually closed more things than actually opened more facilities.
It's up in the Yorkshire where the mines first closed under Margaret Thatcher and stuff like that, and you can see it's never really been the same after that. All steel comes from India.
But even that now, the steel, exactly. So the steel plants here have closed down, and now we're sourcing that as well. And it's like nothing is made here to keep costs down.
They just can't do it. Effectively, in my opinion, what the government is trying to do is that they have these frameworks basically where all this funding is kind of put into. But the frameworks are more just how are you going to, as a consultancy, deliver these projects? It's not about. Then none of the key questions are, do you actually produce this in-house? Do you actually make these in-house? Steel pipe work and stuff, yes, you'll get fabricators in the country who can create pipe work, but not on the sense of these massive solar panels and stuff. Like heat pumps, for example, which is like the big thing at the moment. Scandinavia's been doing it for years and years and years. It's only kicked off here in the last 5 years, I would say. But Scandinavia's been running off heat pumps for many, many years, air source and ground source. So
there's so many technologies in Europe and outside of the UK that are developing way ahead. I mean, nuclear is one of them. Look at France for decades. I know that has its own issues and stuff like that, but the fact that they've been working on that technology, growing it, understanding it, they're understanding it, their technicians, their engineers are way ahead of us. So if we ever even want to come close to like entertaining the idea, like you said, we have to get consultants from over there. We have none here because we're not working on the technology. So We've got like environmentalists saying we shouldn't do this, but if you've got no one working on the technology or to improve it, how are we ever going to actually know? We're relying on data from somewhere else.
Well, and this is the other part of it. When technology comes new into this country, say we touched upon with Scandinavia, like I said, they've trialed and tested and perfected their solution for that country and within their environment of temperatures and demand.
Exactly, yeah. The infrastructure is different to ours.
So, but the quick thing over here is like, oh, it's new. Let's go and heat pumps is great, and it doesn't use gas anymore. Let's go and get those. But again, you have to. You can't just pluck it over and bring it over here. It has to be in. There is a trial and error period as well. That yes, you can put it in first. It's not going to be great in the first instance. You usually get second generation, third generation of that technology that then becomes bespoke to these conditions and these environments over here. And before gas, like I said, before carbon reduction came in, utilizing gas to create power was the biggest thing. It was the name of the game. We have these technology called combined heat power generators. It's called a CHP. Effectively, it's an external engine that you're utilizing gas to create electricity. And for clients, it was the best thing because you're paying 10p a kilowatt of electricity, but you're paying 2p a kilowatt for gas. So it's straight away you're going to a fifth of what you are paying. And if you have got large 24/7 consumption on site with data centers, call centers, you've got gyms that are 24 hours, so the pools are open and stuff like that. They have a massive base load. And that's where it was like, this was the best thing in the world to put in. So it's now you had a technology that was great for that let's say, not necessarily problem, but there was a scope, and now you're trying to get a new technology that wasn't necessarily designed for that scope, but you're trying to make it applicable to it. That's like the big challenge of it all. But that's what the government is trying to push. It's like, okay, we know that we had these solutions in place, but that's now obsolete. We don't want to use gas anymore. How do you meet that same requirement and keep all those customers happy?
It doesn't also help you've got heavy levies on electricity.
Oh yeah, it's got worse. Like, obviously, it's coming down now, but even for private, public
even
sector, it's horrible.
I mean, how long have levies been on electricity? It's been decades now, right?
It's been decades.
I'm so surprised that hasn't changed.
What, like one of our clients, what they have, and this is what a few of them started doing now, is that councils aren't just one entity anymore, and the reason for it is, if they go bust, then the whole thing goes bust, basically. Like you've seen Slough councils had major issues with financials, for example. So they all have the council, and then they'll have an energy company that's basically a subsidiary of that council as well. And what they end up doing is they'll go to their suppliers. They'll actually buy electricity in huge numbers, and they sell it out. So rather than, for example, if you lived in a particular council, the supplier would know, okay, you're living in that council, you would actually get a subsidized rate from them. So in order to get past the levy, they're basically buying mass amounts in bulk up front, saying that we're going to build 2,000 new homes across all these high-rise and stuff that are going up, and we're going to supply it there. So the supplier's like, all right, cool. If it was just going out to people living in these houses one by one, we're going to put the levy on. But if you're going to buy it in bulk, we'll subsidize it for you, and then you subsidize it out. That's the only way it tends to work now.
Yeah, but it's almost like the homeowners end up picking up the price because the levy's put on it to begin with, right? So it's not actually going down.
And this is where it gets difficult. It's quite a touchy subject. Is that there's a lot of social housing as well. So people who aren't necessarily homeowners and they get funding and benefits, etc., to pay for it. That's what makes it more difficult for them. Let's say the person who's not on benefits and stuff, that they end up having to pick up more through tax. That's where it becomes very, very difficult. It's like another whole conversation in itself in that. But yeah, with stuff that's coming up, bills aren't just high because they're high. Bills are high because some aren't paying them, and therefore others have to pay it.
Yeah.
And this is how the government then manages the taxes to then make sure it's not crazy.
I mean, there's so much in there to kind of talk about. I mean, policy decision making, technology. There's so much, and I know obviously that I can't lump that all on you.
But it's all a part of that, right? Yeah. Because we're talking about reduction, and we're talking about savings. Yeah. Unfortunately, people, and we saw this. It's a massive a behavioural thing as well. If you're not paying the bill, you don't care. We've seen it. Honestly, we've implemented solutions in all these in some of these other buildings where we've had to put sensors in everywhere just to make sure it's something as simple as the lights turn off when no one's there. Yeah, people just leave shit on. People leave heating systems on. People leave all the lights on. The building's empty.
Yeah.
Why is it all? Why is it still on? Everything should be off.
Yeah, I mean, I think it's like I had this conversation with one of my friends. It's like with the middle class, obviously the people that it's affected most are obviously kind of raising it as concerns, living costs and stuff like that. But then you've got the middle class or the upper middle class where they are aware of these issues, but because they got so many conveniences that they can cut down, it's not affecting them.
Yeah.
So, like for example, some people have so many and I'm just using this as an example. They got fucking Netflix, Disney, they got Amazon. They got these are just conveniences. So when a bill goes up, they can cut that back, or they'll just cut back their coffee, which is once a week. It's not affecting them too much until their conveniences go down to where they have no conveniences, just like the people that can't afford them. Then they'll be like, well, you know what? No, exactly. But at the moment, the upper middle class and obviously the rich, they have so many conveniences that they'll just cut back one of those conveniences, which isn't really a convenience to them anyway.
It's not a necessity.
That will go exactly.
Yeah.
And it's such a shame that we're not all on the same page about electricity bills and obviously gas bills. It's just all over the place.
Yeah.
And it's a shame. But obviously, like I said, we could talk about that all day long. But let's talk about onto the technologies that you're working on. Obviously, in obviously commercial buildings. Obviously, you mentioned a few already.
Yeah.
But obviously, the main thing we want to talk about is homes.
Yes.
You mentioned obviously boilers, heat pumps and stuff, and batteries. Let's talk about that. What are the kind of innovations that you kind of worked on, and obviously what people should be aware of? Because heat pumps have been in homes for quite a long time, or they've been pushing it, right?
They've been pushing it more now.
We've heard some horror stories, and I don't want to kind of go on that too much because the whole thing is to put the positive side of this. But how has technology moved forward? How are you dealing with the variants of houses? You're kind of looking at each house differently. You've got new builds, you mentioned. I think we had a conversation about the push to put these kind of technologies in new builds.
It's like you have to now. So that's the stuff that the government's enforced now. So as a company where I work, we don't do domestics too much, but we always have conversations with our subcontractors and our designers of what they do. And a lot of them do domestics. It's like a fundamental part of their core business in the year. And this is the thing. So a lot of the technologies, when they do come first, they're only appropriate or applicable to commercial use. So like you said, we were touching on solar farms. You need shitloads of space, right? And quickly touching on solar farms, the rates that they would get to sell back to the grid back then are nowhere near what they're near now. Now they're completely much lower. That's what was huge for farmers to do it back in the day, because you'd set it up and you were selling back to the grid. I can't recall exactly how much, but I know it's a lot better then than it is now. But now, like you said, you can get solar PV on your houses and stuff like that. And even on, like, we've done solar PV on the London stadium, the West Ham football stadium just now as well. Whereas before, you'd never do something like that on such a high-profile building. So the technologies in general that were especially harnessed on renewables were only for commercial, let's say, use before. Whereas domestically, new builds, like we just touched upon there, I think you actually have to have solar PV on them now. And there's quite a few grants coming out. And I think it's like $7.5 grand you can get towards getting your boiler system upgraded to a heat pump system, which will be an air source heat pump system. You can get ground source heat pumps as well. Ground source heat pump in general, layman terms, is essentially boreholes in the ground where you utilize the geothermal properties of the ground.
How far? Sorry, before we come on, how far are you digging down?
It depends. So it depends on where you are. So I did a project in the University of West London in Ealing, where we did 34 boreholes at 189 meters deep. So very, very deep. But then I did another project in Northwick Park for Brent Council, which was a horizontal array. So not very deep at all, maybe about 5-6 meters deep. But that was like your underfloor heating kind of pipe work. So it was an array like that, like a slalom, like an S. It depends. So again, another team in engineering, you've got geothermal engineering. There's people who are educating, design, they've done their qualifications to be able to assess land at different times of the year. How much heat is actually in that portion of the land? How they do that, I don't know, but it's another skill. And it's utilizing natural resource. How much heat is in the ground that you can effectively preheat the water before it goes into your heating system, your mechanical heating system. So your internal, if it's a boiler, is doing less work. It's just it just makes life easier. So you're essentially preheating the water before it goes into the boiler. It kicks less. Air source is different. Air source heat pump is a mechanical system where it's just literally drawing air in, heats it up. That air is then used to then heat the water and then heats it up. So the difference, one of the biggest differences on a domestic use, especially, is that boilers, be it in commercial or domestic, it's on off, right? You would heat the water to a certain temperature, and then it will come down before you have a deadband. It'll say, okay, it's gotten too cold, I want to turn it up. Or you have a thermostat in your house. You say, the house has gone too cold, now I want to turn it up. So you basically have a profile like that, peaks and troughs. Whereas a heat pump is designed to have consistent temperature all the way through. You don't turn it off.
Yeah.
It's designed that it's there, that it will maintain your house.
It's like your refrigerator.
Yes, basically. Yeah. But refrigerator is closed. So you've got your refrigerant, and even refrigerator, it will know once it's reached temperature and it will back off. You hear your refrigerator ramp up and ramp down. But with a heat pump, that's the biggest difference. That people are like, why is it running all the time? Why? Because you'll have a time schedule, for example, like we do in schools. Before with boiler systems, you'd be like, okay, kids are going to start, or staff are going to start coming in from 7:30, 8 o'clock for if they go breakfast club or something like that. We'll rank the heating up at 6 o'clock in the morning. So it's got a good hour and a half to preheat, get the building ready. A heat pump you just leave on the whole time.
That's one of the questions I had when trying to do my research on this. Like, why would you leave it running during the summer periods? Isn't that just...
No, but it would maintain temperature. So it will know when it's reached temperature and it will back off. So you have internal temperature sensors, you have external temperature sensors.
So is there a rate where it ever be like, you know what, this is too hot, like in the summer?
Yeah, of course. I don't need to run. It will know I don't need to run. So it's similar in the boiler in that sense. But like, yeah, if I've got an outside air temperature, like in summer, I've got a sensor outside. It's saying it's 22 degrees outside. My internal sensor, I want it to be a bit cooler even inside, but I'm just going to set it on like 15, 16. It will know. The systems are so the systems now are smart enough to say I don't need to just run constantly.
Yeah.
There's no demand. And again, with technology and how engineers have now understood it, it's understanding when is the demand, when does it need to ramp up, when does it need to ramp down, and when can it just be off. It's understanding, and then all the data that comes in from, which I mentioned, so sub-metering and metering is so key in that, is that we've got these cloud-based systems with Siemens, for example, where all the meter data goes into these, and we have the capabilities in-house now to download that data and assess it, to be like, does this trend look right? Does this look wrong? Is the consumption too high? Like is the meter wrong? Sometimes they're reading 0. You think, shit, that's not right, because they're getting bills coming in. They can't even assess why is it doing that. It's understanding all of that. And then domestically speaking, heat pumps is basically what's coming next. Heat pumps, solar PV, batteries is now the other thing. It's having all these bits in. Because a quick one was that you touched upon like how many different bits we have in the household now, with equipment becoming more smart, with it becoming basically needing constant power sources and stuff. Before, things used to be on and off. Now you do have like your Hive system, your meshes and all these kind of things. If you've got a server in the house, you've got fans, you do have quite a high base load now. So with that, it's very good to have these technologies in, because they'll just cover your base load.
Yeah. So in terms of like, what's the aim of the game here? Is it to make homes more efficient or self-sufficient? Because that's one of the big things, right? And the reason why I ask that is because I see online where people are just kind of like, especially engineers who know what they're doing, they're literally getting themselves off the grid, right? They're installing these batteries, they're installing solar panels, where it's all just literally off the grid, right? And how truly are they off the grid? Because when I see some of these engineers doing it, they've got the space to install several batteries. They've got the space to install God knows how many solar panels to make it adequate for everyday use, especially in the UK here, where we're working from home. Our energy, usage is shooting up, right? With energy usage now, everything becoming electrified. As energy usage goes up, like how are we ever going to be like either self-sufficient or kind of keep our energy footprint lower? You can't. It's gonna no matter how much technology we put in, it's going up and up.
You're 100% right. So this is what we're doing more on a commercial perspective now. It's not necessarily to be completely self-sufficient, but is to be self-reliant in need of quick response. And what I mean by that is what we're doing at the moment is near massive service stations, basically outside the M25 belt and everything. It's under highways. We're making huge battery storage systems next to there. Because that's where the space is. That's where the network can actually connect up to as well from the grid that we were touching upon earlier. It's all great making all these systems, but if the grid can't actually supply to it, it's pointless.
Yeah.
And that's what we're seeing, is that with some of the bigger projects now, where they're actually saying, can you slow down? Because we can't afford to keep you guys on for another year when the connection's ready. We can't play your prelims. We just can't do it. Can't afford to keep you guys on as a manager. Can we either halt the contract, or can we just call it here, and then we'll either call you back when it's ready, or you just don't know what's going to happen. But it's all about, actually, it's not necessarily being completely self-reliant at the minute. What my opinion of it is being for quick response, that for hospitals, for army barracks, for essential services, if there was a cut in the grid for whatever reason, can they actually continue to function? So the drive in the country at the moment is more so for essential services to have quick response effectively. It's not, they become self-reliant hubs, yes. And unfortunately, in this, let's say, climate of the world, there's a lot of war happening. And it is basically tailored at that. If war kicked off, because gas, like I said, it's not produced in this country, it comes from other places. It comes from Russia through Europe. If it's cut off and there's no supply, what are they going to do? They need to, so that the government's drive, it's not obviously pushed in that way to scare people, but the push is become self-reliant for essential services first. So as a country, A, we're protected, and B, we can still function. Otherwise, it'll be anarchy. If for example, people find out there's the army's down, but if there's no hospitals, no police, there's no fire, there's no this or that, you're going to have riots and just looting happening left, right, center. So the drive at the minute is for that to happen. The second part of it is, as you mentioned, is because we're being basically coerced more and more to use less and less gas. Like even your hob now, a lot of people have induction hobs rather than your traditional gas-fired hobs that you had before. So like the induction hob is becoming very popular now. More and more electricity is coming in. So as I mentioned, it's your base load for the actual electrical requirement in your property is now higher. Now, the applicability of these technologies being installed on your home, like you said, it depends on space. Is it actually in the right in the right location? I.e., for solar PV, you don't want to install it if your roof is facing in the wrong direction. You want to be facing the right direction so you're actually getting the arrays. If you've got lots of trees covering over your property and stuff, again, there's no point. You're going to have shadows. So it's all good that the technologies are there, but are they actually applicable to your home? Air source heat pumps is basically the biggest one that is going to be appropriate, just purely because it replaces your boiler system. And like how some people have system boilers and some people have combi boilers, you can tailor your air source heat pump system to prioritize on your heating circuit, or you can prioritize your domestic hot water circuit, or you can even get 2 heat pumps. They're not huge. Again, with the further development of these technologies, and we were chatting about this earlier, things were massive before. Computers were huge before. If you think about it, now they're tiny. The amount of information you get on your phone and the technology that was in just your phone was back in the day was humongous, probably bigger than here. And same thing with like heat pumps. First they were huge, now they're tiny. They look like AC units on the back of houses. So how it looks isn't the prettiest and stuff like that. But if you've got AC, for example, you can put a heat pump there. It does the same thing.
So before we move on to kind of some of like the technical issues that I want to raise with you, in terms of someone looking to kind of get a heat pump system, what kind of pre-requirements are there? Because as we touched on new builds, now new builds don't have that problem because you plan the whole thing from floor to kind of roof, right? You plan it, you've got the space, you're literally starting from scratch, right? So you don't have those issues. But where you got like Victorian builds, old houses, lack of space, for example. I mean, space will. I mean, that's not something you can overcome, right? But what do people need to be aware of if you want to get like a heat pump in a Victorian house? Is there anything you need to do beforehand?
It's a really good question. So it's all good putting, let's say, a brand new technology in, but like I say, if you have got quite an old home and the insulation, for example, is not great, and you've got a lot of losses, the efficiency of that heat pump is not going to be good. And this is where people love boilers. Boilers will just smash it. They're powerful. They utilize gas, but boilers, as long as you've got good rates. So this is the other thing. It's all good having a great boiler, right? But if you've got tiny radiators, or you have no radiators, for example, as a complete extreme example, it's not going to do anything. So it's all about actually having the design done correctly. Now, I say design, you don't have to be the most technical person in the world to do a proper design for radiators, But you know, if you've got a big space, you need more radiators. If you've got lots of windows and stuff like that, you're going to want to put the heating source close to the window so it creates the barrier so you're not getting heat loss. It's more so bits like that in general layman's terms, right? So you want to make sure if you're going to put in a heat pump system, if you're feeling that your home is just not getting heated up, you need to look at the pipe work. Is the pipe, has it got blocks? And have you got air in your system? It could be something as simple as that. People don't vent their radiators. We had them off the whole, let's say you had them off for 6 months during the summer period and then it gets cold. You haven't vented it. You've got air in your system. You need to get the air out the rads, they'll heat up. So I would say, in very general terms, check if you've got any cold spots in the house. Do you have radiators in them? Yes. Are they getting hot? Yes or no. Have they been vented? Yes or no. You can get even like the adjustable AAVs on them, basically, which means you can open and close the valve as much as you need to. So you can, it goes like normally in general term 1 to 5. Have it on 5, it's fully open. Have it on 1, or 0, it's closed. But it's just balancing your system as well. That if you've got quite a big home, do you have a pump that's actually helping the water get out, or is it you got it in the loft and it's now coming down? Is it struggling to get back up? There's so many factors to it. But any decent firm, there's loads of domestic plumbing firms out there and stuff like that. They'll have their wits about them. They'll know what they're talking about. Yes, it's very, very difficult getting work done because builders will take the piss.
Yeah, because that's what I was going to come on, like all these prerequisites, especially from the home before the kind of the heat pump goes in. If, like you said, if you're already like there's lots of leaks in the house, or it's not very energy efficient or whatever, right? There's not enough insulation. They've got to tackle those first. The heat pump's not going to do anything, and I think that's where a lot of, I wouldn't say. Well, there's some very good companies, right? And you can see them because they're still around now, right?
Yeah.
But obviously, when schemes were first introduced, a lot of firms open up just to kind of get on the government funding, right? And then they go bust. And that's very unfortunate. You can hear about that on other channels. People have talked about it, right?
Yeah.
And people get caught out. But even now, it's almost like the aim is to get the heat pump installation in there rather than assessing the house. It's like the customers contacted them. They've asked for a heat pump because it's part of some scheme. We kind of want to be green as possible because, you know, that's what we're kind of told to do.
Yeah.
So, and we're as normal consumers, we don't know nothing about heat. We don't know nothing about heat loss, right? We go to work, we come back, you know, it's cold. Okay, I need to fix this. But I don't know where to start.
Yeah.
Someone will come in and be like, oh yeah, look, you need a heat pump. I'm just going to get you this heat pump. This is what you do. But they're not going to talk about the heat loss, that other things, because their aim is to sell you the heat pump. They're not an installation company. They're not going to fix windows and stuff like that.
Precisely.
So they're going to come in, and this is from my understanding of what I've seen.
You're absolutely
and it's
right.
like, so they install the heat pump, and then they will service it, and now they're bleeding money, the consumer, right? They're bleeding money. And they haven't solved the problem.
You end up reverting
exactly.
back.
Like boilers are still, boiler installations are still kind of outperforming heat pump in this day and age, even though they're supposed to stop. And it's like, because you get, like you said, you get that hot burst of heat, even regardless of the heat loss. You get that wave of heat coming at you, and the loss is slower. And it's like, how much responsibility is it of the company installing me? Look, you know, there's heat losses happening here. You need to address these issues first before we can come in and install this equipment. Rather than, oh, look, we've got a customer here. I'm going to install the equipment.
Everything you said is basically what our company does. Like I said, the responsibility is absolutely on us. That these are government-funded schemes, which is basically taxpayers' money. And if we just piss it away, basically saying, yeah, we'll do this, it'll be fine. But we, like I said, we know we won't even get paid unless we're hitting our savings targets. And that's what we say. Our solutions aren't just this one thing will fix everything. It's a combination of projects. We call them energy conservation measures, ECMs. It's a portfolio of this that will help you get to this end goal. You can't just have one. And it's like a very, very simple thing, like with the heat pumps. Let's say Joe Bloggs will just come in and be like, okay, you've got a 15 kilowatt boiler and I'm going to put a 15 kilowatt heat pump in. They're not the equivalent. A 15 kilowatt boiler is very, very different to a 15 kilowatt heat pump. There's a lot of factors to it. And this is what I meant about the teething issues when these new technologies were coming in. If in Scandinavia, they know the heat pumps inside out, they were like, yeah, it was that, we need this. Whereas people have looked at, okay, it was that, we think we need that. We think. So it's very, very difficult. You have to take that calculated risk. Are we putting enough safety factor into our calculations to say, okay, if it doesn't really perform as what we think it would, what do we do? And this is where hybrid systems come in, which are very, very good. You leave the boiler as well. So if you find as though it's freezing cold winter, we have cold snaps over here.
Oh, yeah, we do,
And this is the other thing. a heat pump can only perform as well as it can up to a certain degree, so like up to like -2 or -3 degrees, especially domestically speaking. Otherwise, you can be talking about huge heat pumps coming in for your home. So to supplement that, people keep the boiler as well. And you simply, all you have is a valve that essentially means that you've got two sources that are coming into one vessel, let's say. So you've got a boiler here, you've got a heat pump, and you've got a vessel in the middle. And if your heat pump's performing absolutely fine, you think, great, I'll close that valve, I'll keep this valve open, and it's going to keep coming in this way. But after a certain period, you think, no, this isn't right. You can have this system, turn off that one, close that valve, open this valve, energize. Your boiler will then just ramp up, smash it out for a good half an hour, whatever it needs, and you'll meet the temperature. The good thing with a heat pump is once you've met the temperature, it will maintain it very well.
Yeah.
The heat pumps can struggle just to get to temperature. That's the biggest thing that people aren't used to. Like you said, you can turn your boiler on for half an hour and you're pretty much there or thereabouts, domestically speaking. The heat pump can't do that.
Yeah. Or not now.
Or not now, anyway.
Also, we need to address that technology is moving forward quite rapidly.
The biggest difference, again, with the UK and stuff, is even when it comes to like batteries, which is the big one, and even solar PV, the regulations and the standards that we call them, that you have, there's many different guides in engineering, right? So you've got SIBC, which is basically a guidance that this is what we think is an appropriate level of heat set points or levels of lighting or controls, etc. Then you get BS standards, which are actually British standards. And that's what you have to abide by.
Adequately named, yeah. BS standards.
Yeah, basically. So you have to abide by those. Yeah. Those are basically fundamentals that if you're not in line with those, you're not compliant. So for solar PV, they've come leaps and bounds in probably just the last 5-6 years, because there was so much stuff that was coming up, going wrong, kind of thing. It was like, no, you have to have this, you have to have surge protection devices, you have to have lightning protection, you have to have this, that, and the other. Things can't be metal, they've got to be in GRP enclosed, you've got all this stuff on the roof. I think it's good, because this is the issues that were happening before. But with like batteries and heat pumps, a lot of it's not even written yet. So it's kind of like this ever-evolving thing of it has to be. But where it becomes challenging is that the government's drive is to do it very quickly. And this is something we weren't even doing 5 years ago.
Yeah.
So to say we're going to achieve this by 2030, which is only 4 years away now, when you weren't even doing it 5 years ago, it's like...
Yeah, I think there's a compromise risk that needs to be made there, because speed. I mean, the thing is, it's quite odd though, because we've seen the mistakes happen. We're seeing them real time.
Yeah.
So the fact that we're not slowing down and reassessing is quite dangerous.
Definitely. Yeah, we're running before we're walking. At the moment,
exactly. And the other thing, like obviously, the major thing of that is obviously rogue companies, right? Opening up, doing shit work for people, and then they kind of like talk about it openly, obviously social media platforms, and that hinders companies like yourselves and other companies, not just yours. There's other companies that are very good. So we don't want to kind of like shit on everyone. That's not what we're trying to do.
We call it greenwashing.
Yeah.
In the business, basically, it's called greenwashing, where they were like, it's going to be this and it's going to be fantastic, and you literally just paint shit green, so people look at it and be like, oh wow, it looks great. But it's actually dreadful.
Yeah.
So now it's even becoming like you can't even have stuff as green and stuff like that. You can't give people the false perception of what you're actually going to achieve or what you're doing in there. And that's why I've got my most recent project now at the moment is right near Barking Gurdwara. We had to do everything blue. But first on the plan, they're like, why aren't we making it green? We're like, it's because it's not that. You can't greenwash it. That people have a false perception of what's actually happening in this energy center. So it's actually a good point on that. So what public sector is trying to do more so is they have heat networks. By heat networks, it basically means rather than having heat sources in every single building, you'll still have some, but the vast majority of the heat is actually stored off-site somewhere else. So what we have these massive vessels outside and the hot water's in there. And when the demand is on the network, the water then flows into the network and goes out. So again, it's a quick response.
Yeah.
That's what what companies and engineers have got better at is designing solutions for this quick response. kind of. But yeah, domestically speaking, it helps domestics as well by having that.
Yeah, I mean, I don't want to go into too many negatives of obviously, because obviously we have to move forward inevitably, right? So I mean, I don't want to. Like I said, there are good companies out there like yourselves and other people out there. You just got to look for them, unfortunately.
Yeah.
Especially, I mean, one thing I'll say on this before we move forward is like just do your research and get more than one. So, for example, you've got Octopus Energy, you've got Heat Geeks. There's so many out there.
Yeah.
Look at all of them. Don't just go for the first one.
No.
Don't go for the first promises that you hear.
Yeah.
And don't say, oh, we're cheap, we'll do it. Understand why they're cheap.
Are you getting a consistent message from at least 3? What we always say is rule of 3. At least go with 3. What you'll end up getting is someone very expensive, someone in the middle, someone a bit cheaper.
Yeah.
See, are they quoting the same things?
Yeah, and are they saying the same thing?
Exactly.
Or is one or some saying some extreme things?
Yeah.
You know, we're going to be the best efficiency ever without addressing, like you said, the home leaks and stuff like that. Just understand. And I know it's a bit tough, but you know,
it's ultimately it's going to add value to your property if you're going to do it as well. But more so for yourself, if you're going to be spending that money and it's your home, you're going to want it to be correct, right? So there's no point trying to rush it. Do it properly. And you'll definitely save yourself. If you do it right up front, it's what we say with any building work. Yeah, if you get what you pay for. If you do the work correctly up front, you'll save yourself a lot of hassle on the back end. If you try and do shortcuts and get it done quickly, for example, in a week, you're going to be spending fuck knows how much just to repair the damage and probably not reverting back.
Yeah. So one thing like I just want to address before we move forward into like technologies themselves, like because I know you're quite keen to talk about batteries and development of batteries and like new solar panels. I know we touched on it briefly, but you know I want to talk about other technologies as well. So not just solar panels. Or stuff like that, other things people can do, or things that are being developed, right? So before we move on to this, the only thing I want to ask is, when you have, so let's use heat pumps as an example, right? So when they were introduced first, they were huge, right? They needed a huge tank. So where people moved old boiler tanks, because we've got combi boilers come in, they moved the tanks out of their lofts or wherever they were. And typical Indians, where you got space, there's a room.
Yes,
right. There's a bedroom, right?
Yeah.
I'm talking about just not Indians, but everyone does it, right? So then we essentially, especially old Victorian houses, where we could combi boilers kind of, and that enabled us to make space in our homes, right? Because tanks were huge, right? So we got that space back. Then we moved into obviously heat pumps, where obviously they introduced that tank back in again.
Yeah.
Some people obviously had the space; they had a closet where they could put these huge tanks in, right?
Yeah.
And they put these in. And that was not a negative thing. But with technology moving forward, we've got to a state where obviously the everything's smaller. The actual tank now, you still need a tank for the kind of people need to know that it's not just a box outside.
It's a vessel.
Exactly. Yeah. So now the pump, they're saying it's small enough where you can fit where your combi boiler would have been inside a kitchen cupboard or something, right? That's where most people have it. And you still got the unit outside. My problem is where this technology was introduced and then it's moving so quickly forward. Isn't the technology already being outdated and customers feeling like, look, it's become more efficient now within a matter of years? That it's like, hold on, a technology that was supposed to save me bills, I'm stuck with it now. You've got newer technology within a matter of years, and I can't have this, which would save me more.
Yeah.
Shouldn't we just keep waiting till it's so efficient, or should we kind of be like, let's use it, let's put it on now? Because it's almost like even like batteries.
It's with technology throughout. What you mentioned that kind of reminds me of televisions a little bit.
So it's almost like I just want to make this point that it's almost like phones. Now it's almost like I've got to change my phone every year, or there's redundancy built into it. It's almost like these boilers would have lasted me years, and they're still there, right? Whereas if I introduce these new things with new technology, with so much software, so much wiring, how long are they going to last before they need to be replaced? And it's a fear that, I'm saving money now, I've got the government scheme now, but how long is it going to last before I need to change everything, before an engineer comes and be like, ooh, it's old now, it's 4 years old, we're not developing the software, the drivers, we don't do it. It's just like cars. They're chucking so much tech into cars. In a couple of years, they're going to stop developing the drivers or the software for them to keep them going. Whereas old mechanical cars with no software, they'll last another 100 years. As long as you've got the pipes and the fittings, they'll still last. I know that's a downer.
No, you basically answered the question yourself a little bit there, in the sense that technology, as you mentioned, is always, you touched on phones, I was saying televisions. I remember when this first like plasmas came out and stuff like that, they went from the big rear view projections to like this, then this, then this, and then you got the LEDs, you got OLED and QLED and all this kind of jazz. It's the same thing with these ones. And like you say, your phones, your Apple release a new one, every year, every 2 years, whatever it may be. It's when are you ready to take the plunge into it? But what the thing I would say, in my opinion, and you're totally right about this, is when the technology is new and it is going through this very much of a teething process of trial and error, and if you're not a techie as it is and stuff like that, it's just going to piss you off.
Yeah, it's almost like the customers are the ones kind of, we're the guinea pigs.
Yes.
And it's very unfortunate because we're relying on this technology that's been introduced to last us.
That's why for us with the bigger commercial stuff, we say don't remove the boiler completely. Leave it in. You need a backup source. Because in case if that cocks up kind of thing, and like I said, we do hospitals, for example, you cannot have a hospital going cold. Like it's just catastrophically bad. But we do works in universities and stuff like that as well. And again, you can't affect, as we say, we can't morally affect kids' educations. These people are going there to study. If they're freezing cold, and we've pissed away a lot of money.
And that's the biggest thing with homeowners. It's money, because regardless of the government schemes,
a grant and stuff like that. Still your money.
Like we discussed before, like it costs about $2-3 grand after all the stuff's been taken out with the government schemes. You still got them, and then they got some form of renovation to the house. You know, you got pipes going in,
you got some sort of renovation.
Going,
correct.
And like you said, if the house isn't already kind of efficient, you've got to look at that work. Otherwise, the heat pump is still going to cost you. So it's a downer. It just needs to be addressed.
But honestly, this is why, as a business, we from Ameresco, we've got a whole other part of it in Bristol City Leap that does a lot with housing, but we don't do domestics purely because of the risk of it. Like I say, not that there's not a risk in commercials, but in commercials we have the room for other pieces of equipment there to be there in case something goes wrong. As engineers, we can say yes, this is plan A, but there is a plan B, there's a plan C. We can remotely control it to say shit, that's not working, disable that, enable, get heat in. And then we'll get to site and do what we've got to do to problem solve it. Domestically speaking, unless, like you said, you've got a company that can very clearly show you, these are the case studies, this is what we've done on the road already. They might say, look, we've already done that house and that house 2-3 years ago, and this is how they're performing. You can go and have a chat with them and just say, look, how does it work for you guys? Because you've got similar homes. It is a thing that, not necessarily it's a risk, but there is risk to it, if that makes sense. And it's just, you have to that calculated approach to it, that if your home is already, like we said, is you feeling that you've got boilers and you have to kick the boiler pretty much all the time because you need the house to get warm, or you've got electric panel heaters everywhere supplementing your radiators, or electric fan heaters supplementing your radiator systems, it's not worth it. You have to assess the house as a whole and get a competent team in to do that. And like you said, not just sell you, oh yeah, you got that, let's just put that in and you'll be fine. You won't be fine.
You need someone to assess the
you need someone
properly.
So as what I mentioned as part of our company, and it's very important to have the team. We have a surveying team. We have a team that can actually go in and assess the feasibility of this is what you currently have, this is what will improve it. Logically and credibly saying.
I mean, I haven't had a survey done on my property, and it's something like I probably will do. But whether some people do it or not, like you said, you do it. Whether someone comes in, I think all companies should do that. Be like, look, you've got to address these problems first.
And it's not an EPC. So energy performance certificate. It's not that. That's okay. It's not this bullshit, but it's a tick box. They don't actually quantify how much of something you have. You could have one room, like you may have renovated one room in your house, you've got LED lighting, they say, yes, LED lighting. Your whole house is not full of LEDs. It's a tick box exercise. It's a proper, you need someone to, and a lot of the time we're like, no, I can't be bothered with that, I'm not going to pay for that. But listen, if you want to get with these new techs, it's different. If you're buying a new build, which is what we're seeing now with the new flats, so you've got new build colonies being made and stuff like that, those assessments should be done. So I worked with some of the, like a new build residential area where they wanted to put heat pumps on the roof, which is what you do. So you get the big plant and you stick it on the roof. And then within your flats or within the house, you've got thermostat, local control, you've got your independent vessel, and it feeds through. So that works. Again, a new build, but even new builds, like anyone who's had work done in their home and stuff like that, even there's teething problems there. You might say it's brand new, why is that tripped out or something?
You know what, new builds have so many other issues, and that's another conversation.
But this is the thing with engineering. You could do it, you could do everything absolutely right, but things happen. And with tech, and this is the thing, so going away from the older mechanical systems to now more computer-based smart homes and stuff like that, there's more stuff that can go wrong. And the difference with the mechanical systems, if something went wrong with the you could actually find what that problem was and replace that
Yeah.
Even as a logical person, you could say, look, there's the leak over there, kind of thing. I'm going to go, what if you got no leaks?
Yeah.
But you're like, why is this not turning on? Like I found my diverter valve on my boiler, it was stuck. I had to trial and error and find where it was. I was like, my vessel's hot, my boiler's working, my radiators are hot. I've got hot water, but my radiators are cold.
Yeah.
This is the thing with the system boiler. And I looked up and they've got 2 valves there, one of them was jammed. So it's having that kind of thing. Oh, it's like, what is it not getting the enable from the controller? Is that what the problem is? Or is the actual module itself, has the actual controller, the valve gone?
Yeah.
And stuff back in the day was so much more robust.
I mean, that comes down to like, I mean, obviously slightly, you shouldn't be repairing your boilers anyway, but I mean, the right to repair and things are becoming less repairable. That's, you know, that's another thing we need to,
it's like we said with cars.
Cars is the worst.
So it's the thing, like, even just to pop the bonnet now.
Yeah, you look at that.
You don't know how to do it.
Yeah, exactly. I mean, one of the things, like, I mean, just from my own experiences, when I bought the appliances for my house, and we were looking to get new washing machine, everything, white goods were practically new, right? We have to get them again. And I just come across these like washing machines that need Wi-Fi access for some of the things to use. Like, why do I need Wi-Fi? I just want on, off, and whatever I'm washing. Like the good old, a couple of buttons, right? And there's plenty of people talking about how washing machines have become unrepairable. They can't fix them. A simple fix, they just chuck it in a landfill, get a new one, goes cheaper. Now that's a different. I don't expect you to put an opinion on that. But even cars now, you know, they're making everything touchscreen just because Tesla did it. They removed all buttons, and it's like, I'm driving. This is more distracting because I've got to look away. For car companies not to realize, have the foresight, like this isn't actually good.
It's not safe.
They changed the buttons to haptic feedback now. But I still got to find the button if it's flat, completely flat. And I think there's reports now going back that cars are now reverting back. And the only reason I want to bring that up is because if companies like that, after years of obviously producing that crap, are reverting back now, we're going to have a similar situation where this technology isn't achieving what it's supposed to be and almost reverting, going back, and at the cost of us.
At the cost of the user.
It's not going to be the cost of government because it's taxpayers' money, right? And it's millions wasted, and they'll just raise our tax. So rather than bills going cheap, we'll just pay it somewhere else. And it's like, that's not. No, it's so difficult for us to make a decision.
Like you said, it touches on that point of how much space do you have in your home. So if you can maintain some sort of hybrid system, it's the better way. It's you reverting from one technology. Oh, sorry, not reverting, but changing from one technology to another, and not having any backup is. Not foolish, but it's risky. That's the word. It's risky. But yeah, like you said, as well, I was saying with some of the tech as well, like if the car comes reverting back, it's the same thing that's happening because they're just like, this just isn't working for us. We've got to revert back to what we know because we've got users, we're hospitals, we're schools, we've got to keep.
And obviously, I mean, don't get me wrong, there are people like yourselves and other companies that are like, look, don't revert back. You know, there are things that we can address to make it more efficient. So it's not just completely rip it out. Because obviously most of those came from bad installations, you know, bad advice from these rogue people, right? The technology is work. I mean, that's why it's there in the beginning, because it's work, right? Like you said, Scandinavia,
it has to be sized correctly. That's what
exactly.
It comes down to design.
So, so we don't want to, I'm not trying to put the message that be like, look, stay away from this. It's not going to go wrong. It's just like, look, when you do it, get it done by the right person, get the good advice, get the right company, right? So it's a technology that is going to help us, right?
Yes, most definitely.
And it just needs to be done by the right people. So I just want to kind of touch on that. I'm not trying to shit on it.
What you've said, Taj, is absolutely right. Technology it's not that it's getting worse.
It's the almost the implementation.
It's the implementation of it, and it's the design. Design is everything. You could get, for example, you could get the best engineers in to come and fit something. They'll do an immaculate job. But if it's designed wrong, it's just wrong.
Yeah, exactly. Yeah.
That's all it is. Unfortunately, it's just wrong.
Cool. Okay, so we're gonna move away because obviously I think that we put everyone fair into boiler upgrades. And
it's okay. Hybrid systems.
Your company's gonna watch this and be like, dude, you didn't do us a favor.
No. But how you? What is it? To plug the business a little bit.
I will definitely do that. Yeah.
No, but like for us, we have hybrid systems. We do go for the hybrid systems as well. But the good thing with us is that we are not, and with any company, what we say is that we are not contractually tied to anyone. Our role and one of our USPs is that we will put the best solution forward for that customer.
You're doing it the right way.
It's not that, oh shit, we've got 1,000 of these sitting in storage, we've got to flog them. Let's just push this product. No, ours is very much, we're not tied to anyone. And if someone does a good service, we'll say,
exactly. All
Yeah,
clearly, you've been
definitely, yeah.
around for how many years now, the company?
13. Yeah, yeah. Oh, Amoresco is so the company which I work for, Amoresco Inc. has been in the States, or in North America for a hell of a long time, and they're number one, if second or number one in what we do out there. But they do massive government military schemes and stuff like that. So they do, we're saying on solar and these kind of bits. They do them on an incredibly huge scale.
Yeah, yeah.
They've then brought that over here. We do it. We're doing massive solar farms up in like Scotland and places where the land is. But I think one of the bits we touched on was like land use. We touched upon properties and being applicable. It's the same for land. It's all good saying, oh, I've got an acre of land over there or whatever have you, let's go put solar over there. If it's not fit for purpose and it's just going to be literally sinking in the ground, or it has massive winds, it's just going to go flying everywhere.
Yeah, there's been a lot of large-scale failed projects, I think. I mean, I came across some of them with like the solar panels, giant mirrors pointing towards something. I think it's one in, I think Africa or something, and one in America. I'm not sure where. I just saw these. There are failed projects on the commercial side. So it's not just all the home side where things, trial and testing needs to be done. That's just an unfortunate side. It's just one of those things. But let's move on to kind of next thing, like new technologies besides like these the heating systems. What else that is being worked on that people can look forward to, or kind of what's going to be introduced in the future?
Batteries. Yeah. Batteries is like the thing that's really, really kicking off now. It's called BESS, battery energy storage systems. And again, what people are doing is using them to supplement other bits which they have on that. So if they've got a small solar PV array, they're using it to charge their batteries now. And the batteries then, again, for quick response, it'll power more of the house, or you can sell it back to the grid. Should you have the space to do so, you can put as many batteries as you like. And hydrogen. Hydrogen fuel cells was something that was discussed many, many years ago. And the biggest challenge is the infrastructure to roll things out on a mass scale. So even with batteries, what you'll see is that what we're doing with highways, you've got these, where you had solar farms, now you have battery storage farms. So you've got these huge containers, like these big cargo containers, and they're full of battery cells, basically, and they'll just last forever and ever, basically, in there. And that's been this whole thing of quick response. If the grid falls down, can we shoot power back into for users and stuff? So batteries is huge. And slowly but surely, hydrogen is going to be the thing that comes forward.
Hydrogen's been around for quite a while.
It's been around for a long time.
Because I remember this whole push when electric cars were being pushed.
And then hydrogen cars, yes.
And the pumps. There were actually some pumps available as well, weren't there?
The biggest thing with it, I can't recall the pumps, but I just remember specifically was on batteries and everything. And the biggest plus of hydrogen is that it's completely clean. The result of it is completely clean. It's basically like it was H2O's coming out. It was like water effectively was coming out of exhaust, like ever so trickling down. But it's clean energy. Domestically speaking, it's too valuable of a commodity to actually use for domestics yet. So it will probably come into commercials first to be used on much larger scale. But that is, in my opinion, is going to be the next big thing that's coming in. The same way how you've seen how you can basically charge your electric car at home. Before there was no EV chargers anywhere, right? And that was the biggest thing. Oh shit! What if I get stuck on the M25 somewhere? And what do I do then? So now the infrastructure is coming to put in these big EV chargers across service stations, petrol garages, and stuff like that. And they've got the high voltage ones. Before it was low voltage. It takes an hour, 2 hours to charge your car, or overnight. Whereas now it's good 15, 20 minutes. You can actually get a good few miles out of it now. That's been let's say, the evolution of just EV charging, which was non-existent before. Obviously, Teslas have gone through the roof, and I say just Tesla, every car manufacturer's basically gone through the roof now with the electric technology. First it was hybrids. So they've all channeled that through. The batteries are too big before. Now the batteries are smaller, you can get more in, you get more range. And so that effectively is what's going to happen. Batteries will keep getting more efficient. They'll probably keep getting smaller, which means that you'll use them, your range for the cars will be even better. Will they create systems that are even quicker to charge cars? Most likely, but high voltage is pretty much as good as you're going to get. Will you ever use it for like ships and planes? I don't think so. Too much risk.
I think it's something to do with the weight of the batteries and
it's just the risk. If the plane has an issue, it's catastrophic. And ships, you'll be surprised how much from shipping is still actually done on ships. Like actual transportation of major goods comes via major cargo. They can't fly that stuff.
Yeah, I mean, we'll come on to this a bit more, like with larger vehicles like ships and stuff. The nuclear energy just lasts for years.
Yeah.
Like submarines is a perfect example of that.
Yeah,
Staying
yeah,
submerged.
yeah.
I mean, besides getting oxygen and getting those people out of there, they can survive
See,
for
but the thing is with
years.
submarines that, oh, God forbid, if something ever happened, they're under sea and stuff, right? It's still that, on a absolutely, like, say, catastrophic failure, is still kind of contained.
Yeah.
My whole, let's say, I don't have too much knowledge with nuclear and going into chemical engineering and stuff, but when you just think of what happened in Chernobyl, in my opinion, that's what the country just weighing up. Either that, or they just don't have they can't source the materials for it.
Yeah.
Because was it uranium and was it plutonium? I suppose
Yeah,
is what's
I mean that's the other thing. Like sourcing materials, like it's all good going green and obviously trying to lower our emissions down and stuff. But these technologies and the valuable metals that we use, they're still being sourced from places that aren't very good at kind of producing these. So how are we supposed to weigh that up? Like all these new technologies to kind of cut our bills are being, I wouldn't say forced, but they're being pushed on us. Gas bills are kind of going up. So electricity is not actually becoming any cheaper. It's just gas is going up.
Yeah.
So it looks like it
pushes.
Yeah, exactly. So if gas
yeah.
goes up, it's not because electricity is cheaper. It's just because it's become cheaper because you push gas up.
Yeah.
So we're not actually saving anything as a consumer. We're just kind of weighing up what's more expensive right now, right?
Yeah.
So like in terms of like if we were to kind of adopt these technologies, we still got to kind of look at the fact that how these things are being made, right? And how do you address those issues if we're not developing?
We think
anything,
ethically speaking, we're just sourcing,
or even sourcing, like
sourcing. So I've
look at both. Let's look at both.
Yeah, no, like for example, like the Middle East, like Kazakhstan, which is just obviously south of Russia, had a huge source of uranium back in the day. And the most random documentary, a bit of random tangent into this chat now, but I was watching that the USSR, as big as it was, had nukes basically dotted all over the place, right? There's like 15 states. And when USSR then disbanded and everything, you had these countries that were rich in these sources, and obviously nuclear weapons was one thing, but they actually had the materials as well. So how the government decides to trade on these kind of commodities is one thing. So America basically bought the uranium from Kazakhstan, effectively during the Cold War, like the early 90s. How the government sources things and from Africa, like Africa is probably the richest land in the sense of minerals, natural resources. How the mining happens and how they sell all of that. Who owns the mines? Like I believe the gold mines are owned by the British still in Africa, and America had huge contracts with Africa to source the minerals from there. Then Trump said something, the president said, "All right, you're not getting anything from us now."
Yeah.
How they source it is I think it's above us to even comment on how they do it. Ethically speaking, like I said, we as a business, I know within the country as well, that if there's certain companies that have been proven or where they're sourcing their labor from to get the minerals and the materials out, if it's done unethically and it's essentially slave labor, there's a Slave Labor Act that we must abide by. That's probably as far as I can go in commenting on that one.
Yeah, that's totally understandable. Okay, so now just open topics really. I mean, we've covered pretty much what you do and obviously what homeowners need to know about technologies.
Yeah.
I mean, I know we talk about future technologies, but in terms of like technology that you think are going to stay, like because obviously technology is moving forward so quickly and changing. It's almost like we're not fixating on one technology. We're moving and swapping and changing, and it's like whatever scheme, like you said, whatever things is a buzzword or something that's let's just jump in. Does it ever feel like we're going to kind of sit down and be like, look, this works exactly, and because it helps us as well as a consumer to be like, look, this is proven, this works. And this is what we should go for based on the evidence. It just seems like we're all over the place.
I think it will happen for a period of time. So it's like boilers. Boilers have been the thing producing heat, as far as I can remember, for 30 years, right? Before that, you had oil-fired boilers. You had different, and before that, it was like log-fired systems and stuff like that, right? It was a lot more manual. So when, like you said, when the formula is proven over a long, it all comes down to it being proven over a long period of time. It can't just be over a year or 2 years. You're talking about 5, 10, 15 years of, yes, this is what the trend is. It will plateau again. that doesn't mean that the technology won't continue to evolve. Like I said, nuclear in other countries has evolved drastically, and like France you mentioned is fully using nuclear. It probably is that there will be a multitude of different technologies used, but domestically speaking and commercially speaking, in like say the public sector, it will just kind of be like, this is what we're using. Whether they're like in military barracks and all these kind of other bits, so they do evolve the technologies. I think it's inevitable. But whether it gets rolled out across, I don't see happening.
Yeah.
The next one, I reckon, like EV, and this is when you kind of get pushed into doing. It's like they kind of like usher you into like buying electric cars because there was no road tax on them. You didn't have to pay congestion charge on them and stuff like that. Now you do have to do both of those things, right?
Yeah.
So it's like there'll be the first kind of was it like dangling of the fruit and the carrot kind of thing? Like these are all incentives is the word I'm looking for. Sorry, to do it. And then once everyone's done it, they're kind of like, okay, now you've got to do this. Now
Exactly.
What was the point?
And,
But that doesn't mean that something else will come and replace it. I don't think, not yet. No.
Yeah, because that's just the fear of the consumer, right? If we're always being asked to change, swap and change, and this is being, like you said, they're dangling a fruit or a carrot in front and just swapping it out with something else,
just pointless.
taking us in a different direction, right?
Yeah.
So it's just good to know where, like, if there's any focus from anyone.
Like, for example, like smart homes are here now. Yeah, technology-wise, they're not going to go. No one's going to rip out all that.
There's an argument to be made there because, yes, I mean, there's a lot of instructivism. I mean, it depends on what we're talking about smart homes. If you're talking about AI and obviously...
That's probably the next bit. That's another conversation in itself, isn't it? Having a droid basically doing everything for you in the house.
I mean, to be fair, that's why we have kids, right? I mean, at least...
Mine don't do anything.
Yet.
Mine makes the mess.
I've got 3 kids and I'm like, you know what? I don't need a robot vacuum. I'll just give them a vacuum to do the vacuum, you know. Build some discipline in them. I know they're not going to go faulty or anything like that. You know, I don't need like to send them back. I'll just be like, just clean up your mess and go. So that's just another issue there. But no, listen. I mean, the other thing, like future-wise, just putting like some engineering hat on. Like, I know you said nuclear isn't your kind of like your field. But it's just when I mean, this is a conversation I want to have with someone, and obviously I'll have it in the future. But obviously, nuclear energy. Obviously, we're building nuclear power plants in Wales now, one of the biggest plants in the UK. So clearly, we're moving forward with that technology. It's not like going away, right? But it's had its hiccups, and obviously, it's like I see like in probably like I don't know 50 years maybe. I just see with everything getting smaller and smaller and smaller, like you've got, nuclear plants being obviously taking up massive acres of land, then going to like submarines, boats, it's obviously getting smaller. Now they're making modular small nuclear power plants, obviously big corporations like Google, Microsoft, to power the AI, right? They're putting so much pressure on the electrical grid already with their server environments. They're almost taking themselves off the grid. They're doing it themselves. They're like, why are we going to pay electrical companies? We can do it. And the way they're doing it is they know nuclear is
the way to do it.
Exactly the way to do it. So clearly, they've seen something the rest of, and they got the resources.
It's that thing because they're generating so much data and all these data storage buildings.
But if they own the electrical grid, like nuclear, if they own it, they've got no one to pay. Exactly, and that's such a shame because that's what we should have been doing. Like I mean, the government should have been incentivizing to like have energy under its own control. It did at one point. I believe it was Margaret Thatcher that broke up.
Sure.
I think it was government owned, one of the electrical firms or something. Time when it broke it up, free market, and you can see how that played out. But just having like obviously these companies have seen that that's the way forward, right? And I'm not saying like we should get all under control again. But I'm just looking into forward. Do you reckon like you'll ever see like nuclear powered homes and you just see like the giant bin at the end of the day with a nuclear van or a truck just comes and plucks those little like the energy sources they have, like just the waste from nuclear waste, just pick it up, take it away.
Nothing's impossible.
I just see nuclear energy being just like obviously regardless of the issues that happened like such a long time ago, we've moved so far beyond that. I know people keep using those as examples, but if you look at the deaths and the incidents, the environmental impact was horrific. But remember, that was a technology when it was still at its infancy. We've come so far from there. France is fully adopted, or nearly fully adopted, and God forbid nothing's happened there. And they improve. I mean, you got to look at that about every technology, right? There's risks in every technology.
100%.
And it's almost like we're not looking at those issues, but we're looking at nuclear because it was such a global event, right?
But it's even like in America, if you look at exactly where it was, I think it was maybe Michigan or something, where they basically polluted all of the water that was coming in, and everyone just became dependent on bottled water after that as well, because it was basically like an island, and off the island they saw there was like radiation poisoning, there was lead poisoning, all this stuff happening. And kids, they were finding in like 30, 40 years' time like why is there such a surge in these illnesses and diseases? Because they were exposed to those kind of environments. Like you said, it was very old back then, and
but to be fair, I mean, those arguments can be made. But look at cosmetics.
Yeah,
lead poisoning, putting that stuff on your face.
Yeah,
I mean, it's almost like fear mongering in nuclear power. I mean, if you want to go that we could pick anything in any different field. Washing up liquids. Shampoos. People's hair falling out. Those were tested on people.
Yeah.
I mean, so it's not just nuclear power, but I mean, I'm just trying to put a positive spin on it.
Anything is possible. Should the government decide to do it? They'll make it feasible, and company will say, yeah, okay, if that's what we've got to be, those are the parameters that we're now working in. We've got to do essentially what the government is pushing. Effectively, that's what it's going to be. And it's like you said there, even with the gas tariffs and stuff, like it's not like electricity's got cheaper, gas has just got more expensive. So in that basically happening, some of the technologies that we were installing before are just no longer feasible.
Yeah.
Because that was the whole point of them before, that they were cheaper than electricity. Now they're not. The government pushing certain things and tariffs changing drives a lot. Effectively, if the government says we actually have no other option now but to go that way, they'll make it happen.
Yeah.
Why they haven't gone that way, I don't know. It's just like you said, maybe someone more so in that industry can dive into the history of it all, of why has it not been adopted as much. If, like you said, Wales, which is still part of UK, is doing it. It's the same land.
Yeah, it's just like I said, like looking 10, 20, 30 years, no matter how long it takes. I just want to see what the future looks like. We promise so much.
Yeah.
And it's like we don't quite get there. It's like,
sure. I think the way it is going, gas will not necessarily become obsolete. It will never become obsolete. But gas will reduce drastically.
Yeah.
And then, like he's mentioned, I can just see, the way I see it is that you're going to have just heat pump galore. You'll have solar everywhere, but there'll be better systems. That's all it is. People will just, like our children, for example, in the future will be like, yes, this is normal for them. They're used to it, and they'll know how to use them properly.
Yeah.
Whereas for us, we are guinea pigs.
Yeah.
Any technology in that generation, in that kind of transition period, is the guinea pig. But it should get better. For sure. But hybrids, in my opinion, hybrid systems are always the best way. As an engineer, as a project manager, you always need to have a backup.
Yeah.
And so it'd be foolish to dive in unless you're absolutely like certain and you're doing the design, you know what you're talking about. Don't be that crazy. not yet anyway.
Yeah. But no, listen, it's been amazing to kind of get your input on mechanical engineering, what you do, and obviously the systems that are being introduced into homes. So hopefully it's been informative. And we need more engineers. So hopefully we kind of incentivize more people getting kids and people
it's
learning.
It's brilliant. Honestly, it's such a good sector. It's so much fun. And just the general skills that you'll learn in engineering.
You're learning so much.
It overlaps into everything, basically. And you'll find that the fundamentals, to kind of conclude my piece on it, is when it comes down to anything, it's time, cost, quality.
Problem solving. I mean, that's the main thing. I think we all lack problem solving skills. I mean,
what we always say in engineering, nothing's impossible. But it comes down to time, cost, quality, all wrapped in health and safety.
Yeah.
That's what it is.
But listen, again, thank you for your time, and hopefully we'll have you back here in the future. It's hard to get hold of you. So in terms of, before we leave, your company,
yes,
if they want to work with your company, work on projects, how can they reach out to them? I mean, do they just open invitation?
LinkedIn for something like this, we'll sort of, let's say, a professional platform to contact on. Ameresco has its own LinkedIn profile. Obviously, I'm myself, Gurpal, I'm on LinkedIn as well.
Yeah.
If anyone wanted to reach out, for sure, we can put you in touch. We have recruiters as part of our company as well who can say where the opportunities are within the company.
Yeah.
There are a lot of opportunities. It's a good thing, as we mentioned, the sector, it is ever growing. It's just doing it at a pace that is realistic and not, like say, running before walking. But the opportunities are there as a whole within the sector, for sure.
Yeah, perfect. Okay, cool. So thank you for being here, and hopefully we'll have you back on soon again.
Ideal.
Thank you.
Thank you.
Cheers.